LibreText, Introductory Chemistry, Section 1.3, Hypothesis, Theories, and Laws. Learning objectives. Describe the difference between hypothesis and theory as scientific terms. Describe the difference between a theory and scientific law. The science of words and definitions is called etymology, and I will use entries from Etymology Online, etymonline.com, to give deeper scientific or linguistic scientific explanations of these words. Although many have taken science classes throughout the course of their studies, people often have incorrect or misleading ideas about some of the most important and basic principles in science. Most students have heard of hypotheses, theories, and laws. But what do these terms really mean? Prior to reading this section, consider what you have learned about these terms before. What do these terms mean to you? What do you read that contradicts or supports what you thought? What is a fact? According to the book, a fact is a basic statement established by experiment or observation. All facts are true under the specific conditions of the observation. According to etymology.com, fact, noun, is from the 1530s, so nearly 500 years ago. Action, anything done, especially evil deed, from Latin factum, an event, occurrence, deed, achievement. In medieval Latin, also state, condition, circumstance, literally, thing done. Source also of Old French fait, Spanish hecho, Italian fatto. Noun use of neuter of factus, past participle of facere, to do, from pi or Proto-Indo-European root the, to set, put. Main modern sense of thing known to be true is from 1630s, from notion of something that has actually occurred. What is a hypothesis? From the book, one of the most common terms used in science classes is a hypothesis. The word can have many different definitions, depending on the context in which it is being used. The first, an educated guess. A scientific hypothesis provides a suggested solution based on evidence. Two, a prediction. If you have ever carried out a science if you have ever carried out a science experiment, you probably made this type of hypothesis. when you predicted the outcome of your experiment. 3. Tentative or proposed explanation. Hypotheses can be suggestions about why something is observed. In order for it to be scientific, however, a scientist must be able to test the explanation to see if it works and if it is able to correctly predict what will happen in a situation. For example, if my hypothesis is correct, we should see X result when we perform Y test. A hypothesis is very tentative. It can be easily changed. From etymology.com, hypothesis, a noun, 1590s, a particular statement, 1650s, a proposition, assumed and taken for granted, used as a premise, which is related to the theory of logic. From French hypothesis or hypothèse, from French hypothèse, and directly from late Latin hypothesis, from Greek hypothesis, base, groundwork, foundation. Hence, in extended use, base of an argument, supposition. Literally, a placing under. For hypo, under, see hypo dash. If you're ever looking for the meaning of a word in English that has certain prefixes or suffixes, Etymology Online, you can, if you go there, you can type in HYPO dash, and it'll tell you what that part of the word means. So if you speak a language that this is used commonly, where you can know what a word generally is about by a part of it, a prefix or a suffix, then you can type them in here and figure out where they came from and what a word really means. It's a great way to read literature and to understand why an author chose what seems like a strange word in that context. Or if you want to listen to a politician and know exactly what they're saying, determine what the word they use means, especially if it's a word they don't use often or if it's a word they use all the time. So from hypo, under, plus thesis, a placing proposition. From reduplicated form of pi or Proto-Indo-European root the to set put, a term in logic. Narrower scientific sense is from the 1640s. What is a theory? From the book. The United States National Academy of Sciences describes what a theory is as follows. Some scientific explanations are so well established that no new evidence is likely to alter them. The explanation becomes a scientific theory. In everyday language, a theory means a hunch or speculation. Not so in science. In science, the word theory refers to a comprehensive explanation of an important feature of nature supported by facts gathered over time. Theories also allow scientists to make predictions about as yet unobserved phenomena. A scientific theory is a well substantiated explanation of some aspect of the natural world, based on a body of facts that have been repeatedly confirmed through observation and experimentation. Such fact supported theories are not guesses, but reliable accounts of the real world. The theory of biological evolution is more than just a theory. It is as factual an explanation of the universe as the atomic theory of matter, stating that everything is made of atoms, or the germ theory of disease, which states that many diseases are caused by germs. Our understanding of gravity is still a work in progress, but the phenomenon of gravity, like evolution, is an accepted fact. Note some key features of theories that are important to understand from this description. And before going on to the features of theories in science, if you are a student in middle or high school or at the university level, at least at the bachelor's level, at a liberal college, liberal arts college, you very likely have different subjects you're studying. Unless it is English, every subject has used the English language to explain itself. Most subjects did not develop from English, except for, let's say, geography or a few others. They came from French, they came from Latin, they came from Greek, they came from Arabic, they came from Chinese. So they'll use English words as you understand them from a common dictionary to define something within their realm. So while you're studying English, whether it's the first language you learned or it's a language you acquired, if it's a language of your household or not, you need to know that in every subject, the way English is used changes. So if you are in a science course, certain words will be different than if you are in, let's say, a government course. And when you learn that English is situational, English is used differently in different environments. This is in linguistics and in communication called code switching. You need to know what the words you're saying mean to the person you're speaking with. So if you say, I have a theory about what the author meant in Catcher in the Rye when he called everyone in Los Angeles phonies, he didn't mean that they were fake people. He meant that they were Phoenicians because many of them arrived by ship. That's an interesting theory. We don't have J.D. Salinger here to ask him. Most people think he just means that they were fake people because they were actors and they always took on different characters. So this is a theory about a book. But if you say, I have a theory about gravity, that it is a mixture of weak and strong nuclear force, someone who's a physicist will say, your theory is correct. And when you make it into physics, we'll parse it out a bit more. Uh, so this is the difference. Your theory in science for 98% of the people on Earth is more correct than they will ever get to. So we'll say that is correct. For the 2% who understand something deeper, they'll say, your theory is correct, but I need to modify it a bit based on recent findings. So unless you are part of the 2% within a science class that knows how to modify a theory that you're given, it is better just to accept it and then say, I have a hunch that this could be different than I'm hearing, and pursue that hunch with your professors or on YouTube or in this book and see what it is that you might have a hunch about, that you think that's different, that you remember that word that they're using weak. nuclear force means something else when translated into Spanish or into Arabic, and you wanna mention something about it, don't say, "I heard at church the theory of evolution is wrong." Well, the theory of evolution is wrong at church because God, and God is a force in addition to being a bearded man in the sky. God causes things to occur. And so, just when he causes things to occur, it is inappropriate, not that it's wrong or it's incorrect, but it's inappropriate to say, uh, I am the reason why that bread is here because I put all the ingredients together and let it rise and then put it into the oven, versus God is the reason why we can make bread. And it just offers a different level of respect. So the theory of evolution is God is the reason why we are here and we should honor him as creator, versus the way you say that God approaches each step. How did the process come together that he uses? Well, this is how it comes together that he uses. So it's wrong to say. You can say at church, I've heard the theory of evolution is wrong. Then at church, hold on to your belief or even your theory. In our classroom, even if it's wrong, this is what the majority of people believe here. So this is our church. In our church, we say something different. And until you no longer have to go to our church school, then you'll have to know at least what we believe. So if you are, say, a Presbyterian and you heard it is wrong to uh, say the Nicene Creed, but it is wrong because the Catholics say it, and you hear the Catholics say it, and you say, well, we should say a different creed that came from before that time period, and we agreed in the canon of Dort, or that this is the way we're going to do it. If you can't go into that explanation, then you need to know why the Catholics say the Nicene Creed. So in their church, they say it. Maybe in your church, you don't say it, but you need to know why they say it and possibly why you don't say it. So if you are in a chemistry course, you need to know why the theory of atomic origin of all things is true, and that there's something called mass and a particle that gives things mass. And then you need to know that mass is technically something different in the Catholic Church. That, well, I go to mass and mass means something different. Well, not necessarily. There is a power that gives mass to mass. And I prefer to go back and forth and see how they overlap. But speak different languages in your chemistry course. You have one language spoken or one set of rules. In your church or other environment, you have another. And it's better to say, I speak both languages, knowing that in both places there may be some dispute. And then, let's say when you're 40, you'll be able to see the continuous line between the two of them more easily than someone who continues to say, no, 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 without having a proper reason why no. Note some key features of theories that are important to understand from this description. Theories are explanations of natural phenomena. They aren't predictions, although we may use theories to make predictions. They are explanations of why we absorb. They are explanations of why we observe something. We are looking at this to verify that it really is the process which causes that. And once we verify it, we'll make it more efficient or find another process. Theories aren't likely to change. They have a large amount of support and are able to satisfactorily explain numerous observations. Theories can indeed be facts. Theories can change, but it is a long and difficult process. In order for a theory to change, there must be many observations or pieces of evidence that the theory cannot explain. Theories are not guesses. The phrase just a theory has no room in science. To be a scientific theory carries a lot of weight. It is not just one person's idea about something. Theories aren't likely to change. From etymology.com, theory, a noun, from the 1590s, conception, mental scheme, from late Latin, theoria, this is from St. Jerome, from Greek, theoria, contemplation, speculation, a looking at, viewing, a sight, show, spectacle, things looked at. From therion, to consider, speculate, look at. From theoros, spectator. From thea, a view. See theater plus horon, to see, which is possibly from Proto-Indo-European root ver, to perceive. Philosophy credits sense evolution in the Greek word to Pythagoras. Going back to my previous point, theo is often a reference to God or divine. Horon has a lot to do with the all-seeing eye of Horus. Uh, Theodos, spectator, is the God who observes, or the watching angels. And then those words were dropped, and then we were able to take them on ourselves and watch and perceive. So again, a lot of this will come together. Um, your church or other group may just want you to listen to what they have to say in their language, and your professors definitely want you to listen to what they have to say in their language. And you will see that there is something called salve and coagula. It will possibly dissolve your understanding of how things are. How is it that one thing can be different in two different places? And then coagula, you'll bring it all together, which is the very foundation of chemistry. What is a law? From the book, scientific laws are similar to scientific theories in that they are principles that can be used to predict the behavior of the natural world. Both scientific laws and scientific theories are typically well supported by observations and or experimental evidence. Usually, scientific laws refer to rules for how nature will behave, under certain conditions, frequently written as an equation. Scientific theories are more overarching explanations of how nature works and why it exhibits certain characteristics. As a comparison, theories explain why we observe, what we do, and laws describe what happens. For example, around the year 1800, Jacques Charles and other scientists were working with gases to, among other reasons, improve the design of the hot air balloon. These scientists found, after many, many tests, that certain patterns existed in the observations on gas behavior. If the temperature of gas is increased, the volume of gas increased. This is known as a natural law. A law is a relationship that exists between variables and a group of data. Laws describe the patterns we see in large amounts of data, but do not describe why the patterns exist. So, one thing that we haven't discussed is the origin of chemistry, at least in the Middle Ages, which is considered from the year, let's say, 1200 to 1600, which is why a lot of these words were changed around 1590. There was a goal by two groups of people. One of them, who again, let's say were the church people, they were trying to figure out how to change their character, how to change their soul to something else. The soul was seen as kind of a gas that operated upon the body and caused it to expand or contract, you can say, or to do different things. And if it overlapped with another substance, it could go bad or good. And so these people would do experiments, usually with sound and, let's say, mantras or rosaries or others, and sometimes with fasting, to change that soul, which was like or spirit, would even be more accurate, which was like a gas around them. And they would do all of these things to change it. This could go to Buddhist monks or Sufi adabs or people who study Kabbalah or some of the great saints of the church, of the Catholic Church. They would do this. And then you had people who read their text, which said that, and this is how you change the lead into gold, or something similar like that. So they set out to find out, well, I want to change lead, which at that time was seen as not very useful. It was a little bit of an additive to wine, and now we know it can cause a lot of damage to the human body. But how do I make that lead into gold? And so you had men and women experiment with different chemicals and substances and temperatures to try to change lead into gold or into silver. And in doing those things, they would write down what worked and what they observed in it. And after a while, those became the early laws of chemistry, that these experimenting methods that again were used for a completely different purpose, which was just for gold, to turn lead into gold, or as it said, to make hot air balloons more efficient so you can go discover. They wrote down what they did during the process, and those became the early laws of chemistry. And then had microscopes and other methods where they just decided to study these laws for themselves, or study these. They had theories and laws, and the chemists, or they were called alchemists at that time, would use what would appear to be strange words. Uh, they would use dragon or elixir, things like that, and these words were translated, and God or demon or to what we now have as modern chemistry, a respectable science, which before was seen as kind of a magic, or something that was so esoteric and difficult to understand. Now we have chemistry as a result of people just desiring these things. Other things later on, for instance, Teflon or Velcro or plastic, we have because we desired to go to space. And we built rockets, and NASA and other space agencies needed certain materials just for the spaceship, and now we have them throughout our whole society. And so, how do you turn lead into gold? Salve and coagula. A lot of people say it's ridiculous to turn lead into gold. Turn into is another one of those phrases that an alchemist uses. And so I'll give you a hint into alchemy. To turn into is how do I dissolve this one thing and only have left the one thing I want? So the way that lead forms and iron and certain other metals, or if you have, let's say, a class ring with a ruby or I have a garnet class ring on, uh, there was a rock that was around it, very likely, and inside a big part of even the stone that you want, there were what we call inclusions. And sometimes the inclusions are what you want, sometimes the inclusions are what you want to get out. And so in a piece of lead, it was very often, let's say if there were 15 grams of lead, there were probably a gram of gold that was mixed in with it. And so if you just took an acid, you would break down all of it and it would just become a mush. But there are ways to take certain acids at certain temperatures and boil away the lead, which again could be very toxic and difficult to deal with. That's why there were books. And at the right time and temperature, you would then have only left gold, pure gold. And that pure gold didn't, it wasn't that the lead changed magically. Well, some people would say it wasn't that the lead transfigured that word as well. It wasn't that the lead became gold. It was that you dissolved the lead only, and what remained was gold or silver. So within that 15 grams of lead, you would never be able to get the gold out. But then you could. It would be like taking a cake and say, "This cake is finished. I just want the vanilla that you put in this cake. I don't want the flour." So most of it's flour and a teaspoon of it's vanilla. You would figure out a way to get rid of all of the flour and other and eggs and stuff like that, and just have the vanilla left. And that's the same thing as turning lead into gold. Okay. So according to etymology.com, a law, a noun, Old English lagu, plural laga, combining the combining form lah, ordinance, rule prescribed by authority, regulation, district governed by the same laws, also sometimes right, legal privilege, from Old Norse lagu, law, collective plural of lag, layer, measure, stroke, literally something laid down, that which is fixed or set. This is reconstructed to be from Proto-Germanic. This is reconstructed to be from Proto-Germanic lagam, put, lay, from Proto-Indo-European root lega, to lie down, lay. The modern word is thus a twin of lay, as that which is set or established. Rare in Old English, it ousted the more usual a and also gesetness, which also were etymologically something placed or set, and which is not here. The geset or goose is the one who sits down on his buttocks and tells you what to do. So it's the king. And so this word law came about when people start moving away from the king being the absolute giver of law to having parliaments and others that wrote laws down or at the stroke of their pen. In physics, a proposition which expresses the regular order of things from 1660s law and order have been coupled since 1796. To lay down the law, 1752, is pleonastic. The law in the figure is biblical law laid down from the pulpit. Poor laws provided for the support of paupers at public expense. Sumptuary laws restrain excesses in apparel, food, or luxuries. It is more common for Indo European languages to use different words for a specific law and for law in the general sense of institution or body of laws. For example, Latin lex, a law, eos, a right, especially legal right or law. Indo European words for a law are most commonly from verbs for to put, place, set, lay, such as Greek thesmos from titheme, to put, place. Old English dome from Proto Indo European the to prefix dhe to put, place, or set. Lithuanian ist etemas from statiti, stataiti, cause to stand, set up, establish. Polish ustawa from stach or stand. Also compare Old English gesetnes above, statute from Latin statuere, German Gesetz law, from Old High German Gesetze, a fixing determination assessment, with Setzen, modern German Setzen, to make, sit, set, put. Words for law in the general sense mostly mean, etymologically, what is right, and often are connected with adjectives for right, themselves often figurative uses of words for straight, upright, true, fitting, or usage custom. Such are Greek nomos, as in numismatic, French droit, Spanish derecho, from Latin directus, Polish prawo, Russian pravo, from Old Church Slavonic pravo, straight, in the daughter languages, right. Also Old Norse ritter, Old English recht, Dutch recht, German recht. See right in etymology or etymology online in the first adjective. And an example, learn to obey good laws before you seek to alter bad ones. Ruskin vos clavigera. And this goes back to the notion that most parliamentary or congressional laws are made for the lowest common denominator, individuals who will not be able to follow a dispensation. You must not walk across a street without uh, without a walk signal first. Or what if there is no walk signal? On and on. Well, these are dispensations in the law, but the law was written in such a way for individuals who would, even if there is a walk signal, would not obey it. All right, so the next section, what is a belief? According to the book, a belief is a statement that is not scientifically provable. Beliefs may or may not be incorrect. They just are outside the realm of science to explore. So from etymology, etymonline.com, etymology online, belief, a noun from the late 12th century, believe or believe, confidence reposed in a person or thing, faith in a religion, replacing Old English Jalitha, belief, faith, from West Germanic Glaubung, to hold dear, esteem, trust. Source also of Old Saxon gelobo, Middle Dutch gelove, Old High German gelobo, German glaube, from galub, dear, esteemed, from intensive prefix ga plus Proto-Indo-European root lèvre, to care, desire, love. The prefix was altered on analogy of the verb believe. The distinction of the final consonant from that of believe developed in the 15th century. The "b", which is not a natural prefix of nouns, was prefixed on the analogy of the verb where it is naturally an intensive. This is from the Oxford English Dictionary, meaning conviction of the truth of a proposition or alleged fact without knowledge, is by 1530s. It is also sometimes used to include the absolute conviction or certainty which accompanies knowledge. Century Dictionary, from circa 1200, as a creed, essential doctrine of a religion or church, things held to be true as a matter of religious doctrine. The general sense of that which is believed is by 1714 related beliefs. Belief meant trust in God, while faith meant loyalty to a person based on promise or duty, a sense preserved in keep one's faith, in good or bad faith, and in common usage of faithful, faithless, which contain no notion of divinity. But faith, as cognate of Latin fides, took on the religious sense beginning in the 14th century. Translations and belief had, by 16th century, become limited to mental acceptance of something as true from the religious use and the sense of things held to be true as a matter of religious doctrine. There is a video 1.3.1. What is the difference between a scientific law and theory? And before I give you the link to it, which is in the comments, uh, when you see a QR code, which is the top left hand corner of the book, and you're reading this in a physical book, say you printed it out, then you can hold up at least an Android camera open over it, open your camera app, and just hover over it, and the camera will overwhelmingly ask you if you want to follow it, this link, and it will take you to a YouTube video. If you have this book, I'm using uh, Google Books to power it, so to read the PDF version and keep my place. Then you can take a screenshot of this page, and then using Google Pictures or Google Photos, you can open up the picture, and at the bottom, you should see something that says search within the photo or search within the picture, and say yes, search within it, and it will find the QR code, and you'll be able to. It'll find the link that's meant for the QR code, and you'll be able to follow it. This is what I've learned. So, one other thing about science and the law and why belief is not appropriate for science. The goal of science is to create usable laws by which we do things. If we establish this is true, this is true, this is true 50% of the time, this is true 75% of the time, then we can create processes by which we manufacture or otherwise live our lives. We can make sure our phones work, we can make sure that our rockets reach the right places. Science intends to come up with shortcuts by which we do things, by which we make things, by which our technology increases, we have easier lives. And one day robots do everything while we probably power those robots, or some of us work, some of us just relax. That's the goal of science, is to give us an easy way to accomplish a goal. A belief, depending on the belief, has a different goal. The belief may hope to establish a law and so be written in a scientific way, but overwhelmingly, it is to a belief is a definition I found recently is very much like magic, where the goal of magic originally was to provide reassurance to people. So if you have uh, let's say a chemical imbalance which causes you to feel a way that you don't prefer to feel, a belief could make you feel better without regard to why it makes you feel better. So, reassurance. A belief can also prepare you for something. So, we can use all the science we want to create laws, but then those laws may lead to an easier way to, let's say, fight war. And so a belief may tell you, even though you have all these laws in place and you can get to war faster, maybe you shouldn't go to war. And so it'll prepare you to have all of these options in front of you, but not use them, possibly. So beliefs are not part of science because science is there to provide a shortcut to an application. A belief may be there to say, even though you have that shortcut, let me prepare you not to use it. Or let me reassure you that even though you have the shortcut and others are prepared to use it, there may be a way for you to survive it. Again, that is the goal of a belief versus a law. Now, for that video I mentioned here, video 1.3.1, on page 1.3.2, a common misconception is that scientific theories are rudimentary ideas that will eventually graduate into scientific laws when enough data and evidence has accumulated. A theory does not change into a scientific law with the accumulation of new or better evidence. Remember, theories are explanations, laws are patterns. We see in large amounts of data frequently written as an equation. A theory will always remain a theory. A law will always remain a law. So the theory of evolution explains how troglodyte over many millennia and eons led to a human being. A law would say 9 times out of 10, this thing does happen. So, is there a law of evolution? Not at the moment, there isn't. And some people would find it very problematic if there was a law of evolution. However, a theory of evolution, which is provable, is probably more comfortable for most people. So, as far as the video that's here, uh, if you don't want to go through all that process or you don't have a phone to do it, um, Video 1.3.1, what's the difference between a scientific law and theory? So you want to go to, let's say, Google Chrome or Safari, into the search bar, or to the where you write the website code in. So this is a type of coding, and write HTTPS colon // www.youtube.com /WATCH V equals GYN2RHBHIEU. Or you can go to youtube.com or open the app and type in, what's the difference between a scientific law and theory? And there is a 5 to 6 minute TED Talk, which is what's present in the book here. Summary. A hypothesis is a tentative explanation that can be tested by further investigation. A theory is a well supported explanation of observations. A scientific law is a statement that summarizes the relationship between variables. An experiment is a controlled method of testing a hypothesis. The contributions and attributions. This page was constructed for content via the following contributors and edited topically or extensively by the LibreText development team to meet platform style, presentation, and quality. Marissa Alviar Agnew, Sacramento City College. Henry Agnew, UC Davis. End of 1.3.